में राई का दाना, रंग बिरंगा बैल सयाना।
उस गडेर में राई का दाना, रंग बिरंगा बैल सयाना।
तुझे पहर में टूटता तारा, पानी पे तिरता पक्का पारा ना।
Hello, I am Angelina Kimidi, member of the organizing committee of KU Hackfest 2022. We are bringing you this event with the motive to provide an opportunity for you to showcase your skills and become part of this excellent learning sharing culture. KU Hackfest 2022 has partnered with Major League Hacking and is powered by Boost Games, who are the diamond tier sponsors for the event. Similarly, the event has GitHub and Solana as gold tier sponsors, Devfolio, Polygon, Tech Himalaya, and Angelswing as silver tier sponsors, Filecoin as a bronze tier sponsor, and Tascade, Interview Cake, Exure, DigitalOcean, Replit, Clerky, Balsamic, and Echo3D as the general tier sponsors. I would like to take this opportunity to thank our sponsors, for this event could not have come this far without their support. We are now bringing to you a session on Angelswing's drone mapping technology. We have two speakers, Ms. Aishma Pant and Mr. Srijak Dahal with us to conduct this event. Ms. Pant and Mr. Dahal are the computer vision research engineers at Angelswing. This session will be 45 minutes long. Without any further ado, we would like to welcome them on stage for this informative session.
Thank you, Angelina. So hi everyone. I hope everybody is doing good. I am Aishma, representing my company Angelswing, which uses the drone technology for creating accurate, efficient, and innovative mapping solution in order to solve the industrial and social problems. So talking about me, I'm a research engineer at computer. I work in a computer vision projects and machine learning projects. So it's been a 1 year here at Angelswing. So we have another speaker, Srizak.
Hello everyone, I'm Srijak Dahal and I'm also a computer vision research engineer here at Angelswing, and welcome all for this session. And I have also been working at Angelswing for a long time, and I've also worked on many AI and machine learning projects. So yeah, it's good to be here. So let's continue with the session.
Thank you, Srizak. So as I said earlier, Angelswing is one of the Korean startup which provides the innovative mapping solution, which helps how the construction job site work, and which also changes the traditional way of mapping into the digital twin platform. So so in this session we are going to talk about different technologies like orthomosaic, real-time image stitching, 3D reconstruction, elevation profile, and safety mapping. So let's go into detail one by one. The first one is orthomosaic. Whenever the word orthomosaic comes to my mind, I always think ortho represents the upright and mosaic represents everything come together, and here it represents the images. So in general form, orthomosaic is grouping images together in order to create a full map. And each images have a certain region of interest. So there might be a question: if there is orthomosaic, if there is a satellite images, then why do we need orthomosaic, right? So in the satellite image, the resolution is quite low, so we cannot trace the objects or elements very easily. But compared to the orthomosaic, orthomosaic resolution is 100 times higher than the satellite image. Also, it is geometrically accurate, so we can easily make the mapping more accurate and more innovative. So here we present the video how the orthomosaic is being done. So we take the images from the different region of the field, and these images is been uploaded to create a full map. So this is geometrically accurate, and also We can also compare the orthomosaic between the previous month and the next month, and we can trace like what kind of activities are being incomplete, and we can make the plan and progress according to this according to this analysis. So some of the tech stack which is used for creating orthomosaic is one of them are drone. Obviously, we take the images, and here we use the DJI Mobile SDK, which controls the software and the hardware interface in the drone, and also UX SDK, so software development toolkit, which provides the UI elements for all the core functionalities. The second most important thing is GCP preparation and detection. GCP here represents ground control points. It is a reference point which is used to establish the actual or accurate position of the drone image. So using the GCP, we calculate the position of the place, and we use RTK, real time kinematics, and PPK to measure the GPS position. And for the requirements to create a GCP there should be at least 3 GCPs, and it should be clearly visible by the drone, and it shouldn't be covered by any kind of trees or vegetations and all this stuff. So we can easily locate the GCP, and we can use it for the image calibration. Another tech for orthomosaic is GDAL, which is after the creation of the orthomosaic, we need to overlay this orthomosaic into the Google satellite or OpenStreetMap. So in order to overlay on the top of this map, we have to make sure that the orthomosaic is geometrically orientated, and it should be well georeferenced. So we need to convert the PNG image or the JPEG image into the T format, which is been provided by the different technology or tools like GDL. Also, there is a geo server for the easy and the reliable method of serving the spatial data, and it can also receive multiple formats of inputs as well as output at the same time. So the second technology which can be used with orthomosaic is the CAD overlay. CAD here represents computer aided design. So it is one of the precise design or a plan for any kind of buildings or the sites. Which is designed by civil engineers and architects. So we overlay the CAD on the top of the orthomosaic to trace out whether the constructions has been done as according to the plans, or we can also change the designs with respect to the constructions or with respect to the time. And the best part about this is the person doesn't have to visit on the site daily, so it can also minimize the time, as well as it brings accuracy with digital training system. So here is a video of how the CAD is being overlaid on the orthomosaic. So it is geometrically accurate, as well as in the next video also we can see the CAD being overlaid over the 3D model. Now the second one service that Angelswing provides is the real-time image stitching. So it is similar to the orthomosaic. In orthomosaic, we give the high resolution image, so it takes longer time. But there are so many cases and situations where we need to we need to make a quick surveillance, as well as we need to identify the disaster. And so for this, a real-time image stitching provides a good help. And as soon as the drone gets the images from the surface or from the regions, the images gets stitched sequentially, and this can be easily seen in the video. So here the images are being stitched sequentially, which helps in minimize the time, and we can easily locate what is happening in the overall region by this orthomosaic. And one of the trending one of the service which is trending in the current time is 3D reconstruction. So Angelswing provides this service, which is being used for the better visualization of the construction areas and buildings. So it provides the high accurate messages as well as the better texture. So yeah, this is some of the example that of 3D reconstruction. So for the tech stack, I've created a brief explanation how the 3D is being reconstructed. So let's go towards the structure from motion. Structure from motion is one of the process of creating the 3D scene from the 2D image. And this 2D images will be the RGB image. It doesn't have the depth information since it is taken directly from the drone in our platform. And it comes across different stages. The first one is image calibration stage. Like I said earlier, we need to set up the GCP, and this GCP will be used for the calibration. The same stage goes here too. For making our images distortionless, we uses the GCP points. But in the case if we don't have GCP, we will be using the metadata of our drone images. Metadata represents different data like the latitude, altitude, yaw, pitch, roll, omega, all these values. We are using these values in order to calibrate the image. To make it distortionless so that it doesn't get affected by the human errors or the sensor errors or other things. Now, and the second stage will be the registration stage. In this registration stage, after the images is perfectly distortionless, this images, the features is being extracted from this image. So extraction of the features can be by different ways. So some of the simplest traditional feature extraction can be features can be shift, surf, or bricks kind of features. Then next comes feature matching. We need to match the features from the different images. And since we take the images from a certain region, so there is a high possibility of having the overlapping region, overlapping areas. So we match the features on the overlapping region of the consecutive images, and we create a sequential matching framework. Then after the images has been matched, we need to estimate the camera poses, which comes under the SFM stage, structure from motion stage. So camera poses is the way of generating the image coordinate system into the camera coordinate system. So we use the extrinsic matrix. So extrinsic matrix basically contains the rotational and transformation matrix. So after the camera poses has been determined, we triangulate triangulate all the multiple views, and then we create the 3D point clouds. So 3D point clouds are the different points, set of different points in the 3D space, and each points represents certain kind of data or informations. Each points has the XYZ coordinate, colors, color values, then also surface normals in the 3 dimensions. So using these values of the points in the point clouds, we will be estimating the mesh. So there are different algorithms for mesh estimation. Before mesh estimation, we will be densifying it because since the sparse point clouds wouldn't be more accurate, and some of the library that can be helped in easy manipulation of the point cloud is PDL, which can also convert the point clouds into different extensions like LAS format or PLY format or LAS format. etc. So this is one of the most helpful in the machine learning and distributed processing purpose. And next comes here the meshes.
Everyone. Hope you are having a great time, and thank you, Aisma. So, after point cloud have been generated, the next step is to mesh it. What does the mesh means? Um, since the point cloud are represented in the 3D coordinate system, we cannot use this as a object because 3D point cloud won't be sufficient for using it in different platforms, such as using it as object in games or in a survey site or construction site as a model. So we need to first make a 3D object by using the point cloud. So meshing is just a piecewise linear surface representation of the point cloud. That means every point which are filtered out, and when the outliers have been rejected, we join the each point with each other, and we create different vertices, faces, and edges for it to be more realistic. Like we can see the triangular mesh of a rabbit. So there are different kind of meshes, rectangular, triangular, and overall it is polygonal mesh. So normally for 3D object, we use triangular mesh. So if the area of triangular mesh is decreased by high factor, then the resolution of the 3D object will be higher, as it will add more details. So after the meshing has been done, we need to do texturing. Why? Because as we can see in the rabbit image, the mesh of the rabbit can be seen, but here is no any image information or any other color information in the mesh. So we apply texture. Texture is just an image which contains the information that needs to that need to be put on the triangular mesh. That means image is laid over a UV map, and it gets swapped around the 3D model. So at last, after applying the texturing method, the 3D model will have color information, and it will also look realistic, and it can be used in different 3D engines, 3D games, or construction site visualization application, etc. So to visualize, we use Cesium. So Cesium is an open source WebGL framework for rendering globe and map. So it is very easy to use, lightweight, and cross browser platform. And here we can it supports many WebGL, WebGPU renderers, and SVG CSS 3D renderers. And for web visualization, we use Cesium.js, which is open source and best in class. And another is also for a game engine. We use Cesium for Unreal. So next. And the next topic is elevation profile. What does elevation profile means? It means the depiction of 2D cross-sectional area of a landscape. That means for a 3D landscape, we visualize how is the elevation changing, and it generates mostly three main objects. So first one is orthophoto rectification. So orthophoto rectification means creating. We have seen already the ortho images or ortho map in the first slide. So it we need to calibrate it using elevation profile, as it can be distorted using different geometrical constraint or camera sensor error information. So using elevation profile, we can rectify the orthophoto, so it can be overlaid on the map nicely. So it is also used for contour generation. So what is contour? It is a depiction of It is a depiction of topography map where the elevation changes over area or elevation. So it gives quite a lot of information for construction site and many other purposes also. And another one is floodplain mapping. So floodplain mapping is used to know which area have a highest rate of flooding. So elevation profile is used in many sectors. So next. So our Angelswing uses elevation profile, we can see here. So this is a construction site whose elevation map can be visualized. So for this line section, we can see the different elevation peaks and valleys, and we can also visualize the past data also and compare it how the elevation has changed over the time or in the period of construction. So it will provide very useful information for surveying the construction site, or it can be used by engineers to calculate the volume density of the sand or the area. So it is quite a powerful tool to have. And the next one is digital elevation model or digital terrain model. It is a topographic model of bare earth, and it contains elevation data in digital format, which means it contains the elevation data of surface of earth, and it doesn't contain any information about the man-made objects such as buildings or skyscraper. It only contains the region where the earth surface or maybe mountain hills and peaks elevation information. And I've explained previously about contour generation and orthophoto calibration. Similarly, it is also used in construction planning, as it can be used to check the steepness of the slope or the region where the construction is to be made. We can first see the digital elevation model to see how the terrain has changed over time, and how we can plan and coordinate the construction process after that. So safety mapping. Safety is one of the most important thing that Angelswing provides. As in construction site, we hear about many people dying due to construction communication errors, or due to disaster that happen due to many cases. So the safety accident occur because actual site is different from situation discussed at the meeting. That means we plan the construction process in the meeting separately, and while performing the construction in action, there occurs some miscommunication or lack of coordination, which causes different disasters or a loss of life. So site planning and coordination helps in safety of the individuals who are working, and it also saves 50% of productivity loss. And next. So yeah, using 3D model to plan and coordinate the construction site, it increases productivity as well as safety. So in this video, we can see the construction site 3D object can be visualized here, and we can add different 3D objects which are used in real construction sites, such as dozers or pipes, cones. And before actually performing the construction operation, beforehand, we can simulate it in the meeting, and check after keeping after routing where the 3D object are placed. It will simulate the equipment positioning and route planning. That means we can put the real size 3D models, and we can check if it causes some hazards or not while doing the construction operations. So there won't be any miscommunication or miscoordination that will cause loss of life and many other issues. So I'm going to show you a quick product demo of our platform.
Job site digital. Job site digitalization, productivity enhancement, and next level construction site management. Start with Angelswing's drone data solution. Let's take a look at how Angelswing brings you the best value of drone technology for your job site. Angelswing improves job site management efficiency through accurate surveys and easy measurement tools. Simply upload drone images to view high-resolution 2D and 3D models. The CAD overlay feature introduces a new way to intuitively monitor and analyze job sites. Precise measurement tools make earthwork much easier. Calculate distance, area, volume, and 3D design based earthwork volume of your job site. And create elevation profiles with just a few clicks. With high data compatibility, work in conjunction with other softwares, convenient sharing and printing features enable quick and smooth communication among stakeholders. Still hesitating to adopt drone technology? With Angelswing, no need to worry at all. Successfully adopt drone technology at your job site with Angelswing's professional consulting service and customized drone operation for your job site.
높은 정확도의 토목 물량을 주기적으로 산출하는 데 있어 가장 큰 효과를 보고 있습니다. 건설 현장에서 엔젤 스윙을 꼭 한번 사용해 보셨으면 좋겠습니다.
Experience construction site innovation with Angelswing, the best partner for smart construction leaders.
So yeah, Angelswing has been leading job site innovation of top 20 construction company in South Korea. From Samsung to Hyundai, many company of South Korea uses Angelswing as their construction site preparation and planning. And we can say overall 70% of top 20 Korean construction company are using Angelswing. So yeah, Angelswing is a digital twin platform for job sites, which means we create a digital version of job site, which depicts the real world job site. And by 2030, Angelswing will create a service where we can monitor anywhere, any place in the world. And that means we can create a digital twin of the whole Earth, and we can visualize and plan accordingly, and we can also solve real world problem by using it.
Thank you so much, Sridhar. So yeah, we have exciting offer for you all. I hope you get a clue or idea about what service Angelswing has been providing and how the mapping solution has been very productive for the job site. So if you wanted to work with us, we are hiring. We are hiring the following roles. So yes, you can apply in the following Gmail of email account, and also you can, if you have any queries, you can also go on our Angelswing Nepal Facebook page, and you can also submit your queries, or you can also go on our you can also go to our Angelswing website, and you can know more about our hiring process and recruitment and available jobs. So yeah, thank you so much.
Thank you, everyone.
We would like to thank Ms. Aishma Pant and Mr. Shijak Bahal for this wonderful session. Now, we would like to ask the participants to continue hacking. Stay tuned for our next session, Why So Few? Women in Engineering. Wishing you good luck for the rest of the event.